Every year, industrial workers are killed or critically injured doing routine maintenance simply because a machine was unexpectedly turned back on. Lethal energy takes many forms on the factory floor: pneumatic pressure, pressurized hydraulic lines, and the kinetic energy stored in heavy, suspended counterweights. To prevent these catastrophic releases, the Occupational Safety and Health Administration enforces Standard 1910.147, the control of hazardous energy. This standard establishes the specific physical and procedural barriers required to keep a routine maintenance task from resulting in a fatal accident. The ultimate objective of the regulation is achieving a zero-energy state. This means the machinery is completely isolated from its power sources and rendered totally inoperative. Isolation requires the use of an energy-isolating device. These are physical hardware components like manually operated circuit breakers, disconnect switches, and heavy line valves. To ensure those isolating devices stay in the off position while a worker is inside the machine, OSHA recognizes two distinct systems: lockout and tagout. While both aim for a zero-energy state, their functional differences determine how much the safety of the work environment relies on physical hardware versus human compliance. Lockout relies on physics. It is defined strictly as the application of a positive physical restraint that holds an isolating device in the safe position. Because industrial environments are highly corrosive and volatile, OSHA requires all lockout hardware to be exceptionally durable, capable of withstanding prolonged exposure to weather, dampness, and chemical environments. Isolating hardware is highly specialized for specific energy sources. For fluid and gas lines, devices like this red plastic clamshell are designed to completely encapsulate ball valves, making the handle physically impossible to turn. Hardwired electrical energy requires different engineering. These red and black toggle locking mechanisms clamp directly onto circuit breakers to block the circuit from being closed. For mobile or cord-connected equipment, devices like this yellow Hubble plug-out cylinder encapsulate the entire plug end, severing the machine from its power source entirely. The final layer of restraint is the lock itself. To be compliant, a safety padlock must be substantial enough that removing it without a key requires excessive force and specialized metal cutting tools, like bolt cutters. When multiple technicians are servicing the same equipment, they use gang clamps. These multi-hole hasps require every single worker to attach their personal lock, ensuring the system cannot be re-energized until the final person finishes their job and leaves the area. By substituting human behavioral variables with an uncompromising physical barrier, lockout serves as the most effective method for controlling hazardous energy. Tagout operates on a different premise. A tag is strictly a prominent visual warning. It provides absolutely no physical restraint on the machinery it is attached to. To ensure these warnings are universally understood across a busy floor, tags must be rigidly standardized by color, shape, and print. They require high-contrast designs and explicit instructions like "do not start" or "do not energize." Each tag must also clearly identify the specific authorized employee who applied it, removing any ambiguity about who is actively working on the equipment.
However, OSHA explicitly warns that tags evoke a false sense of security. Because they lack a physical barrier, their effectiveness relies entirely on every single employee noticing, reading, and obeying the warning. To prevent a tag from simply falling off or being casually brushed aside, the regulation mandates a physical fail-safe. The attachment must be a non-reusable, self-locking nylon tie with a minimum unlocking strength of 50 pounds. The absolute regulatory mandate for any tagout system is clear. A tag is never to be bypassed, ignored, or defeated by anyone other than the specific person who attached it. While tagout provides essential communication, its reliance on human psychology rather than mechanical physics makes it an inherently vulnerable control method. OSHA categorizes workers into distinct roles based on these operational vulnerabilities. The individual uniquely trained and responsible for isolating the energy and applying the locks or tags is the authorized employee. Once applied, the authorized employee maintains exclusive control. The physical lock protects them regardless of what anyone else on the floor does. The second category is the affected employee. This is typically the machine operator whose job requires them to be in the area, but who does not perform the actual maintenance. If a facility relies on tagout instead of lockout, an affected employee poses an extreme risk. Failing to read a tag out of habit, they can easily turn a valve and energize the system while someone is inside. For this reason, affected employees are required to undergo specific training, simply to recognize when energy control procedures are active and to understand why they must not intervene. A physical lock actively protects both the authorized worker inside the machine and the affected operator outside of it.
Tagout demands perfect, continuous behavioral compliance from every person in the building. Because of these human factors, OSHA enforces a definitive hierarchy. If an energy-isolating device is capable of being locked out, employers must use Lockout. Tagout is not treated as an equal alternative. Lockout occupies the top tier of this hierarchy because its physical nature actively prevents accidental startup at the source. If a machine physically cannot accept a lock, a tagout program must incorporate at least one secondary safety measure, like removing a valve handle or an isolating circuit element, just to approach the baseline safety level of a padlock. Furthermore, whenever older machinery undergoes major repair, renovation, or modification, the regulations require the facility to upgrade the isolating devices so they can accept physical locks moving forward. Every component of this system serves one objective: maintaining a zero-energy state to ensure no machine part moves until it is safe. Possessing the standardized hardware, the specialized clamshells, the multi-hole gang clamps, and the 50-pound test nylon tags is only the foundation of compliance. With the physical tools understood, we have to analyze the procedural exceptions, mapping exactly when these strict rules apply during heavy maintenance and when they differ during normal production operations. It is a common misconception that lockout-tagout procedures only apply when a machine is completely torn down for major repairs. In reality, everyday production actions routinely place workers directly in the path of hazardous energy. This energy takes many forms: electrical, mechanical, hydraulic, pneumatic, chemical, and thermal power. The requirement to isolate these sources triggers under two conditions: if an employee bypasses a safety guard or places any body part into a machine's point of operation. Then, production stops. The moment the physical barrier between a worker and a hazard is compromised, the operator must completely isolate the machine from its energy supply. As we see in this OSHA documentation, the cord and plug exemption allows bypassing full lockout if electricity is the only hazard, delivered via standard plug. However, the employee doing the service must maintain exclusive control of the unplugged cord. Walking away from the unplugged machine immediately breaks that exclusive control. Stepping across the room to grab a wrench means you can no longer guarantee someone else won't plug the equipment back in. When control is broken, a physical barrier is required. Here, we see a yellow plug-out device securing the cord end so it cannot be inserted. Distance destroys control. If you cannot physically keep your hands or eyes on the plug, a physical lock is mandatory to prevent accidental re-energization. The minor servicing exemption allows certain quick tasks without a padlock if they meet 3 rigid criteria. The task must be routine, repetitive, and integral. Clearing a standard material jam qualifies. Fixing a sudden breakdown does not. Even if a task meets those 3 criteria, the worker must still be shielded from hazardous motion. This diagram shows alternative effective protection, like a safety-rated light curtain, that automatically halts the machine's cycle if the boundary is crossed. Stating that a task will only take a second never justifies skipping safety protocols. If a procedure truly qualifies as minor servicing, it requires heavily engineered safeguards to replace the missing padlock. Let's apply these strict criteria to a real-world manufacturing scenario to test your understanding. This is a UAW fatality report outlining an incident on an assembly line. An operator halted an automatic line and stepped inside a robotic cell gate to replace a malfunctioning pneumatic valve. The report outlines the sequence of events. The operator pulled the gate interlock plug, entered the cell, and removed the defective valve while the machine was stopped, but not locked out. We will put 5 seconds on the clock. Based on the criteria we've discussed, does this valve replacement qualify for the minor servicing exemption? Why or why not? The answer is no. This operator does not qualify for the minor servicing exemption. Looking at the conclusions of the report, 2 fatal flaws emerge. Replacing a broken valve is an unpredictable repair, failing the test of being a routine production task. Furthermore, relying on a single gate interlock does not provide effective alternative protection. Because this was a repair task, the equipment required complete de-energization. As shown here, main electrical panels must be secured with physical padlocks before entry. Actual maintenance and repair work is distinct from normal production. Regardless of how fast a part can be swapped out, unplanned repairs demand total energy isolation. Let's review. Lockout is required when bypassing guards or entering danger zones. The cord and plug exemption demands exclusive physical control of the unplugged cord. The minor servicing exemption is strictly for routine tasks backed by effective alternative protections. OSHA exemptions are highly specific tools for tightly controlled situations, not everyday shortcuts.
Welcome to This Explainer. Today, we're taking a top-down look at OSHA's absolute requirements for controlling hazardous energy in the workplace. We're going to focus really heavily on those non-negotiable employer mandates and the incredibly strict hardware standards that go right along with them. So if you manage maintenance workers, or operate machinery, or honestly just care about workplace safety, this is your definitive guide to understanding exactly what needs to happen before a piece of machinery is ever serviced. To really grasp why this matters so intensely, I want you to consider two numbers, 120 and 50,000. When hazardous energy isn't properly controlled, workers are exposed to massive risks. OSHA estimates that strict compliance with these very lockout/tagout standards prevents roughly 120 fatalities and 50,000 serious workplace injuries every single year. That's huge. And when these injuries do happen, workers lose an average of 24 workdays just trying to recover. So this isn't bureaucratic red tape, right? This is a literal lifeline.
So here is our roadmap for today. We'll start with the Energy Control Program, then move into procedures, training, and inspections. From there, we'll cover device exclusivity rules, hardware standards and durability, and finally, tagout limitations and requirements. Let's dive right into Section 1, the Energy Control Program. It all starts at the top with the employer's fundamental mandate. OSHA is crystal clear here. Employers absolutely must establish a formal, documented energy control program. The whole goal is to guarantee that employees isolate machines from their energy sources, whether that's electrical, mechanical, hydraulic, pneumatic, chemical, you name it, and render those machines fully inoperative before any servicing even begins. Look, if there is even a slight potential for unexpected startup or a release of stored energy, this program has to be firmly in place to protect your team. Moving on to Section 2, Procedures, Training, and Inspections. You can think of OSHA's core administrative demands as a stool with 3 legs. These are your foundational pillars of compliance. First, you've got documented procedures that spell out exactly what employees must do. Second, comprehensive training tailored specifically to your authorized and affected employees. And third, periodic inspections of these procedures. And don't miss this detail, those inspections must happen at least annually. This is a continuous loop of safety, not just a one-and-done setup. As an employer, your procedures have to explicitly outline the exact steps to shut down, isolate, block, and secure your machines. Literally, no guesswork allowed. On the training side of things, you've got to ensure workers truly understand how to safely apply, use, and remove these energy controls. The authorized employees actually doing the work need to recognize the hazardous energy sources, while affected employees basically just need to understand the purpose of the procedure and, most importantly, know to never, ever tamper with a lockout device. To guarantee these procedures actually work in the real world, that mandatory annual inspection comes with a very specific rule. The inspector has to be an authorized person who is not actively involved in using the specific procedure they're evaluating. Basically, you can't grade your own homework. They're there to ensure the steps are followed perfectly, verify everyone knows their responsibilities, and confirm the procedure still offers adequate protection. And yes, you have to formally document that this inspection happened. Okay, shifting from the administrative side to the physical tools, let's look at Section 3, Device Exclusivity Rules. Whether you're using a lockout or a tagout device, OSHA has a zero-tolerance policy for hardware mix-ups. The padlock you use for your gym locker or to lock up your toolbox, you can never use that on an industrial circuit breaker. LOTO devices have to be singularly identified and used exclusively for controlling hazardous energy, period.
You can't use a LOTO lock to secure a fence gate, and you can't use a standard master lock on a heavy machine. They have to be the only devices authorized for this purpose in your building. And a specialized plug lockout device is a perfect example of why this exclusivity rule exists. When a worker sees a bright, specialized unit clamped around a power cord, there is zero ambiguity about what it's doing. It isn't just locking something up for convenience, it is actively performing a life-saving function. If LOTO devices were used for everyday, mundane tasks, they just blend into the background. And honestly, that's exactly when fatal mistakes happen. Because industrial environments are incredibly unforgiving, let's jump into Section 4, Hardware Standards and Durability. Think about seeing a specific bright green lock and a heavy-duty red warning tag on an electrical panel. OSHA requires these devices to be standardized within a facility by color, shape, or size. So when an employee sees that green lock, they instantly recognize it as part of the Hazardous Energy Control Program. It establishes this immediate, unmistakable visual language across the entire plant floor. But standardization is just step one. The hardware has to be incredibly tough. These devices must be durable enough to withstand their specific workplace conditions. If you're working in a wet environment or around highly corrosive chemicals, the tags and locks cannot deteriorate or become illegible. Plus, they must be what OSHA calls substantial. This means a lockout device should only come off if someone uses excessive force, like hauling out heavy-duty bolt cutters. Accidental removal should be virtually impossible. And, of course, every device must clearly identify the specific employee who put it there. Even in complex group scenarios, like when you have a whole crew needing to lock out a single energy source using gang clamps, that hardware rule remains absolutely strict. The clamps have to be rugged, weather-resistant, and entirely uncompromised by whatever environmental hazards are in that room. Each worker places their own personal, uniquely identified lock onto the clamp, ensuring the machine absolutely cannot be re-energized until every single person has safely removed their specific lock. All right, let's wrap up with the critical differences between the two methods in Section 5, tagout limitations and requirements. The big difference here comes down to physical reality. A lockout device provides a positive physical restraint. The machine physically cannot be turned on without the key or those bolt cutters. A tagout device, on the other hand, is fundamentally just a prominent warning. Because tags don't physically stop a machine from being switched on, they are way easier to remove, and dangerously, they can create a false sense of security. Because of this, OSHA considers locks to be vastly more secure. If you use a tagout system on a machine that could be locked out, your employer has to implement extra safety measures to guarantee the exact same level of protection that a lock would have provided. And when tagout is used, OSHA leaves absolutely nothing to chance with the hardware. You can't just tie a tag on with a flimsy piece of string. The standard mandates that the tag attachment has to be non-reusable, attachable by hand, self-locking, and non-releasable. Specifically, it needs a minimum unlocking strength of no less than 50 pounds. Essentially, it needs to be equivalent to a heavy-duty nylon cable tie. There is no master key for a tagout tie. It has to be destructively cut off. To ensure maximum clarity and prevent any kind of catastrophic miscommunication, those tags also have to be highly legible with standardized formatting. The legends, the actual text on the tags, must offer clear, undeniable instructions. OSHA gives us specific examples for this. Do not start, do not open, do not close, do not energize, or do not operate. The wording simply leaves no room for interpretation. We're going to leave you with this absolute foundational rule of OSHA compliance. It states, only the employee who applied a lockout/tagout device is permitted to remove it. Now, yes, there are extreme, documented exceptions for emergencies, but this is the golden rule. It completely relies on the exclusivity of the hardware, the clarity of the procedures, and the rigorous training of the staff. So, I want to leave you with this thought. When you walk your own facility floor tomorrow and you look at the nylon zip ties securing your warning tags, would you trust your own life to them? Because when it comes to hazardous energy, ambiguity isn't just an OSHA violation. It's a matter of life and death. Okay, let's dive right into this. Here is our roadmap for today. 1. The hazardous energy threat. 2. Understanding LOTO. 3. The step-by-step procedure. 4. Safe removal and restoring power. 5. Specialized situations. And finally, 6. Training and program inspections. Section 1. The hazardous energy threat. Before we can mitigate a hazard, we have to know exactly what we're dealing with. We're talking about the unexpected energization, the startup of machinery, or the release of stored energy during maintenance. If it can move, crush, burn, or shock you, It has got to be controlled. Moving right along to Section 2, Understanding Lockout/Tagout. To actually neutralize these threats, OSHA requires specific physical tools and defines very distinct roles for everyone involved.
First off, there's a critical difference in roles. You're either an authorized employee or an affected employee. Authorized workers are hands-on with the LOTO process. They physically apply the locks. Affected workers, on the other hand, just operate the machines or work in the area. If you're affected, you must respect the perimeter and absolutely never interfere with the locks.
Next up, lockout versus tagout. They actually aren't the same thing. Lockout uses a physical positive restraint, like a heavy-duty padlock. Tagout just uses a prominent warning device, like a tag, without any physical restraint. Lockout is always preferred, and tagout is only acceptable if it provides a level of protection absolutely equal to a physical lock. Now, what's really interesting about this setup is how the physical lock acts as a positive restraint, while the tag serves as a mandatory, prominent warning against unauthorized removal. Together, they are a real game changer for safety. OSHA basically says that if an energy isolating device is capable of being locked out, you must use a lock. This means if it has a hasp, a built-in lock, or can be blocked with things like circuit breaker blocks or cord end isolation devices without permanent alteration, you have to lock it out. Section 3, the step-by-step procedure. This right here is the absolute heart of the explainer. It's the core action plan that must be followed. Think of it like a giant puzzle. Employers must develop separate energy control procedures if their workplaces have multiple energy sources or different control sequences. These procedures must detail specific steps to shut down, isolate, block, and secure machines. You literally cannot rely on broad generalizations here. And seeing a lock securely holding a switch firmly in the safe-off position brilliantly illustrates the physical reality of an energy control procedure. It ensures no one can accidentally throw that switch while someone is elbow deep in the machinery. Now, before beginning service, you must complete 6 steps in exact sequence. 1. Prepare for shutdown. 2. Shut down the machine. 3. Disconnect or isolate the machine from its energy source. 4. Apply the lockout or tagout device. 5. Render safe all potential hazardous stored energy. And 6. Verify the isolation and de-energization of the machine. Skipping even one of these steps, especially that final verification step, can be fatal. Section 4. Safe removal and restoring power. Believe it or not, re-energizing a machine is actually one of the most high-risk moments of the entire process. Before removing devices, you've got to inspect the machine to ensure it is operationally intact and check to assure everyone is positioned safely away. It is extremely important that all employees respect lockout and tagout devices during this phase. So, the crucial point is this absolute rule. Read it with me. Only the person who applied the device may remove it. I'll say that again because it's that important. Only the person who applied the device may remove it. Respecting this rule is completely non-negotiable for protecting lives. Section 5, Specialized LOTO Situations. We know the real world is complicated, right? Sometimes you have multiple workers, or you need temporary power. When a crew is working together, each authorized employee must apply their own personal lock to a gang clamp, ensuring everyone maintains individual personal control. The machine stays off until every single lock is gone. Now, what if you need temporary power for testing or positioning? Well, you have to follow a strict 5-step loop. Clear tools and materials, clear employees from the area, remove devices per standard, energize and test, and then immediately de-energize and reapply your devices. Protection must be immediately restored. Finally, Section 6, Training and Program Inspections. Having a great procedure on paper is totally useless if people forget it. Training is absolutely not a one-and-done event. Retraining is legally required whenever specific triggers hit, like changes in job assignments, new machinery or processes, new energy control procedures, or if you find shortcomings during periodic inspections. And speaking of inspections, OSHA requires at least one periodic inspection annually. But here's the catch. It must be performed by an authorized person who is actually not involved in the specific procedure being checked. This guarantees a completely objective review. So, I'll leave you with this. Are your energy control procedures truly protecting your people or just checking a box? I highly encourage you to go out, review your workplace procedures today, and make sure they are really ready to save a life. Thanks for watching, stay safe, and I'll catch you in the next explainer.
So today we're diving into something that is absolutely critical for workplace safety: OSHA's control of hazardous energy, or as you probably know it, Lockout Tagout, or LOTO. Specifically, we're zeroing in on the training, roles, and requirements that literally ensure everyone goes home safe at the end of their shift. I'm really thrilled to guide you through this, because understanding these rules, it isn't just about checking a compliance box, it's about protecting lives. Okay, let's dive into this. We've got 6 key areas to cover today: the stakes of energy control, authorized versus affected employees, training for other employees, triggers for mandatory retraining, certification and record keeping, and finally, fostering a safety culture. All right, Section 1, the stakes of energy control. Before we even get into the who and what of training, we really need to set the stage on why this matters so much. Hazardous energy isn't just some regulatory buzzword, right? It's a life or death issue on the facility floor. 3 million. Think about that number. That's the estimated number of craft workers, operators, and laborers who face the absolute greatest risk of exposure to hazardous energy while they're servicing equipment. Whether we're talking electrical, mechanical, hydraulic, pneumatic, chemical, or thermal energy, if a machine unexpectedly energizes or releases stored energy while someone's working on it, well, the results can be catastrophic. And to put that into perspective, OSHA states that compliance with the Lockout/Tagout standard prevents an estimated 120 fatalities and 50,000 injuries every single year. Let that sink in. And for those unfortunate enough to get injured on the job from hazardous energy, they lose an average of 24 workdays for recuperation. I mean, that is a massive, massive toll on the worker, their family, and the whole facility. So, to stop these kinds of accidents from happening, we turn to the ultimate legal authority on the matter, Title 29 CFR Part 1910.147. This is the OSHA standard that spells out the exact required steps employers have to take to disable machinery and prevent that unexpected release of energy. And the absolute foundation of that standard, it's training. Moving on to Section 2, authorized versus affected employees. This brings us to the who and what of the training requirements. Think about your own facility for a second. Who exactly needs LOTO training, and what specifically do they need to know? Well, the answer is that practically everyone needs some level of training, but the depth of it depends entirely on their job title and what they do day to day. Let's break down the 2 main roles. First up, we have the authorized employee. By definition, this is the person who actually locks out or tags out the machines to perform the servicing or maintenance. Think of them as your hands-on implementers. They're the ones physically applying the lock and controlling the energy source. Because these authorized employees are right there in the direct line of fire, their training curriculum is, understandably, the most rigorous. They need specific knowledge and skills to safely apply, use, and remove energy-isolating devices. They have to be trained to recognize hazardous energy sources, understand the type and magnitude of the energy they're dealing with, and completely master the methods to isolate and control it. Next, we've got the affected employee. This is usually your machine operator or user. Now, they don't perform the actual maintenance, and they aren't the ones doing the lockout/tagout activities themselves, but their job requires them to operate the machinery or just be in the area where the servicing is happening. So we're looking at 2 very different roles here, right? Which brilliantly illustrates their completely different training needs. Your authorized workers, the implementers, have a highly technical focus, recognizing and isolating those energy sources. Meanwhile, your affected workers, the operators, have more of a behavioral and conceptual focus. They must understand the fundamental purpose of LOTO. But most importantly, they need to recognize when a procedure is happening and know the absolute, non-negotiable rule of never tampering with lockout devices and never trying to start up locked-out equipment. Which brings us to Section 3, training for other employees. Now, you might be wondering, what if you aren't turning a wrench and you aren't operating a machine? Well, OSHA doesn't leave anyone out of the loop. The standard explicitly states that other employees, anyone whose work operations are or even might be in an area where energy control procedures are used, must receive instruction. Basically, just walking through the facility means you need a basic understanding of LOTO and the strict prohibition against removing a device or trying to restart machinery. Now, what's really interesting here is the use of tags. If a facility uses a tagout system instead of a physical lockout system, OSHA actually requires an extra layer of education. Every single employee, authorized, affected, and other, has to receive specific training on the limitations of tagout devices. And understanding those limitations is absolutely crucial. See, a tag is essentially just a warning device. It yells, "Do not operate." But unlike a padlock, it doesn't provide any actual physical restraint. Because of that, tags can sometimes evoke a false sense of security. OSHA generally considers physical locks to be way safer and more effective. But if tags are used, every worker has to be trained to treat them with the exact same respect as a physical lock, knowing they must be securely attached to withstand at least 50 pounds of force. All right, Section 4, Triggers for Mandatory Retraining. So this covers the who and what, but what about the when? Getting everyone trained initially is a massive achievement, for sure, but facilities are dynamic. Things change. So, is LOTO training a one-and-done event? Absolutely not. Initial training obviously happens before someone starts servicing equipment, but maintaining a truly safe environment, that requires ongoing vigilance. In fact, all roads lead back to mandatory retraining when things shift. Employers have to provide retraining for authorized and affected employees whenever specific triggers happen. Got a change in job assignments? Retraining required. Brought in new machinery with new hazards? Retraining required. Changed the energy control procedures themselves? You guessed it, retraining required. And crucially, if a periodic inspection reveals a gap in an employee's knowledge, or even if an employer just suspects there's a gap, that failed inspection means retraining is mandatory. The goal here is always to reestablish that safety proficiency. Next up, Section 5, Certification and Record Keeping. You know the old saying, if it isn't documented, it didn't happen. Well, OSHA definitely operates on that principle. So the crucial point here is that employers are legally obligated to certify that training has been completed for all covered employees. And we aren't just talking about an informal sign-in sheet. The certification must formally state that the training was accomplished, and it has to include each employee's name and the exact dates they were trained. This applies to both the initial training and any of those mandatory retraining events we just talked about. Keeping these records accurate and up-to-date is totally non-negotiable. And finally, Section 6, Fostering a Safety Culture. We've spent a lot of this explainer digging into rigid rules, definitions, and, documentation requirements. But we really can't lose sight of the human element here. All of the legal texts, the strict definitions of authorized versus affected workers, the rigorous curriculums, it all culminates in one single physical act. A properly applied, exclusive lockout device is literally the final physical barrier protecting a worker's life. Proper training is what ensures that the lock goes on when it should, stays on as long as it must, and is completely respected by every single person in the building. So I want to leave you with a question to really chew on. Does your facility's training program clearly separate the who, what, and when? Do your authorized maintenance crews know exactly how to isolate energy? And do your affected operators understand exactly why they must never, ever bypass a lock? I highly encourage you to take a hard look at your own LOTO programs today, because at the end of the day, knowledge is safety, and applying that knowledge is what ensures every worker goes home safe tonight. Thanks for joining me on this explainer, and keep learning. So we're diving straight into OSHA's requirements for controlling hazardous energy today. Now, if you're an authorized worker or an employer, you already know the basics of lockout/tagout. It's your lifeline. But what happens when standard procedures just don't quite fit the reality of the job? We're going to tackle those really tricky edge cases, the complex exceptions you actually face on the floor. Here's our roadmap today. We'll be hitting 4 real-world scenarios: testing and positioning machines, group LOTO and shift changes, working with outside contractors, and finally conducting annual LOTO inspections. Let's jump right in. Section 1. Testing and positioning machines. Managing temporary exceptions. Let's look at a major hurdle that comes up all the time.
Okay, picture this. You're right in the thick of a complex repair. The machine is locked out, you swapped the bad part, but you actually need the power back on to see if your fix even worked. Or maybe you just need to jog a component into position. You obviously can't leave the locks on, but taking them off mid-job, that feels like breaking the cardinal rule of LOTO, right? Well, thankfully, OSHA gets it. They do allow temporary removal of your devices for this exact situation. But, and it's a huge but, the conditions are incredibly strict. To stop an accident during this super vulnerable phase, you literally have to follow a non-negotiable 5-step cycle. First, clear all your tools and materials out of there. Second, get all employees out of the danger zone. Make sure everyone is completely clear. Third, safely remove your locks and tags. Fourth, energize the equipment and run your test. And finally, step 5, before you do any more actual maintenance, you must immediately de-energize and reapply your LOTO controls. Like I said, it's a tight, strict cycle.
Section 2. Group LOTO and shift changes, maintaining continuity. So what happens when a job gets bigger than one person?
When that 5 p.m. whistle blows and the machine is still in pieces, you can't just toss the keys to the next guy or leave the equipment unlocked. There has to be an orderly, documented handoff between the outgoing and incoming shifts. The incoming crew actually has to verify the energy isolation for themselves. You really can't just take the last shift's word for it.
And if a whole crew is working on something massive, the absolute golden rule is personal control. That means every single worker needs individual control over those energy sources. You can't just have a supervisor slap one lock on the main breaker and say, "All right, everyone, I've got you covered." No way. That's a recipe for a catastrophic miscommunication. This is what personal control actually looks like in practice. Every authorized employee puts their own distinct personal lock on a group lockout mechanism, like a hasp. When you finish your specific part of the job, you take your lock off, and the machine literally cannot be re-energized until every single person has cleared out and removed their personal lock.
Now, your teams might use different hardware depending on the energy source, like circuit breaker lockouts on one hand, or maybe a bright yellow cord end isolator on the other. But the underlying principle, totally identical. It's your lock, your life.
Moving on to Section 3, working with outside contractors, synchronizing safety.
Things can get pretty messy when third-party contractors come on site. Honestly, assumptions here are dangerous. You might assume they use the same tags you do, and they might assume your operators know to stay back. In these cases, explicit communication isn't just nice to have, it's your ultimate safeguard.
The on-site employer and the contractor absolutely have to mutually exchange their lockout procedures before any work starts. And here is the kicker that trips a lot of companies up. The on-site employer is actually responsible for making sure their own team understands and complies with the contractor's safety program. If they use a different colored lock or a specific tag, your local team needs to know exactly what that means and steer clear.
Section 4. Conducting annual LOTO inspections, proving compliance. Let's talk about holding ourselves accountable.
You might have a great program on paper, but OSHA requires you to prove it's working by doing a periodic inspection at least once a year. The most crucial rule here? You can't grade your own homework. The inspector has to be an authorized person who is completely independent of the procedure they're evaluating. They need to physically watch the workers do the lockout and verify no one is taking shortcuts.
And when that audit is done, a simple "looks good" won't cut it. Your certification needs to be airtight. You have to document the specific machine, the exact date, the names of the employees who were audited, and the name of that independent inspector. That paper trail proves your safety culture is actually operational.
Section 5. Summary and call to action. Building a safety culture. Let's bring it all together.
You know, a lot of people just see OSHA as the enforcement cops, right? But if you're an employer, especially a smaller one, OSHA actually offers free, confidential, on-site consultation. It's a massive resource to help you spot hazards and improve your programs without the looming threat of citations or fines.
If you want to take it a step further, OSHA has cooperative programs like SHARP or the Voluntary Protection Programs, also known as VPP. Jumping into these can drastically drop your injury rates, save you a ton on workers' comp, and could even get you exempted from routine programmed inspections. It really shifts the mindset from just getting by to proactive excellence.
At the end of the day, hazardous energy is a hidden danger. A pressurized air line looks exactly like an empty one. A live wire looks dead. But a properly executed lockout/tagout program, maybe even backed by OSHA's consultation help, strips that danger away and protects everyone on your floor.
So we've covered testing machines, shift changes, contractors, and audits. The rules are strict because the stakes are literally life and death. Always verify isolation, respect the locks, and ask yourself today, are you taking shortcuts to save 5 minutes, or are you making sure every single worker goes home safely tonight? Stay safe and lock it out.
Here's our roadmap for today. We're going to hit the stakes, contrast the frameworks of 1910-147 and 1910-333, clear up the lockout versus tagout reality, dig into your company policy Bible, and finally, look at individual safety.
Section 1. the stakes, and understanding hazardous energy. Now, when you hear the phrase lockout/tagout, it's super common to picture a breaker box and think strictly about getting shocked. But the hazards are actually so much broader than that. Hazardous energy encompasses mechanical, hydraulic, pneumatic, chemical, and thermal energies. Just think of a massive pneumatic press that could suddenly cycle, or a hydraulic arm dropping out of nowhere, or maybe steam unexpectedly releasing from a pressurized valve. If any of these energies unexpectedly release, or if machinery suddenly starts up while someone is servicing it, it can cause severe harm. We have to control all of it.
Section 2. The frameworks. Let's look at 1910.147 versus 1910.333.
Now you really need to know the explicit distinction between these two rules, because they do different things. 29 CFR 1910.147 is your broad general standard for the control of hazardous energy. It's designed to prevent the unexpected release of stored energies, mechanical, hydraulic, pneumatic, you name it. But, and this is absolutely crucial, 147 explicitly does not cover electrical hazards that arise from working directly on or near premise wiring and electrical conductors. Those specific electrical shock and burn risks, those are covered by 29 CFR 1910.333. So think of it this way. The two standards work in perfect conjunction. 147 stops the machine from suddenly starting and crushing you, while 333 stops the raw electrical circuit from shocking or burning you while you're working on it.
And when we look closely at 1910.147, there's a core philosophy here that you absolutely must grasp. This standard is built as a framework of absolute minimums. These are hard stop requirements. So what does that actually mean for an employer? It means you can always tighten the safety rules. You can always add more robust procedures to your program to make it safer, but you can never, ever loosen them or take away from the baseline that OSHA provides. It's a floor, not a ceiling.
Section 3. Lockout versus tagout reality. Let's clear some things up.
We need to dismantle one of the most misrepresented concepts in the industry right now. The biggest myth out there is that a tag must be placed with a lock every single time a lock is applied. That's actually false. Now sure, a lot of employers simply bake that rule right into their company policy, and hey, that is totally fine. Like we just talked about, you can always make rules stricter. But the way the OSHA standard is actually written, lockout and tagout are two completely independent concepts. You use either or, depending on the situation and what the equipment is actually capable of. What's way more important are the standards for size, color, and markings applied to them. Ultimately, for all authorized and affected employees on the floor, your specific company policy is your ultimate authority for what you're required to adhere to.
To put this into perspective, a true lockout device is a positive restraint. Think about a circuit breaker lockout mechanism, or a heavy-duty danger lock physically securing an electric switch. No one can just casually pull these off. They literally cannot be removed without the specific key, or without using extraordinary, destructive means, like actually coming at the lock with heavy-duty bolt cutters. It provides real, physical security.
Now, a tagout device, on the other hand, is essentially a prominent warning mechanism. It provides absolutely zero physical restraint. Because it relies purely on warning people not to re-energize the machine, OSHA has incredibly strict rules if you're going to use one. A tag has to be fastened with a non-reusable, self-locking nylon cable tie, basically a really beefy zip tie that requires a minimum unlocking strength of 50 pounds. It's meant to be tough to break, for sure, but remember, it can still evoke a false sense of security compared to a physical lock.
Whether you're using a lock or a tag, the real OSHA mandate here is strict standardization. These devices have to be uniquely identified within your specific facility by color, shape, or size. And here's the golden rule, folks. These locks and tags cannot be used for anything else. You cannot take your assigned red LOTO lock and use it to secure your gym locker or your personal toolbox. No way. They must uniquely identify the authorized user and be exclusively dedicated to energy control.
Section 4. The Company Policy Bible.
So OSHA provides the framework, but the company policy has to be written in a way that makes it your absolute control of hazardous energy Bible. What I mean is, it should be concise and explicit. There should be zero room for personal interpretation. Every potential question should be answered in this document. Any and all tools incorporated into your process need to have a detailed explanation of their role, their purpose, and exactly how they're intended to be used inside the program. Generalizations in a document like this are incredibly dangerous.
I like to call this the 3 a.m. test. Picture this. A solo authorized maintenance worker is on the night shift. It's 3 a.m. The main line just went down, and there is absolutely no administrative support or supervisor around to ask for help. If they are reviewing the requirements they need to adhere to, does your written policy have enough detail and specific procedural steps to give that worker the resources they need to make perfect, life-saving decisions entirely alone? If the answer is no, that policy needs an immediate rewrite.
And keep in mind, this policy isn't just some static document that gathers dust on a shelf. Employers are required to conduct periodic inspections of these energy control procedures at least once a year. An authorized inspector has to verify that employees truly understand their responsibilities and are executing the steps perfectly. If there are any deviations or inadequacies, they must be corrected immediately. It is a living, breathing compliance cycle.
Section 5. Individual Safety. The ultimate rule. This right here is where policy becomes practice and where lives are directly protected. The absolute most crucial point to understand is this. Lockout is designed to be an individual safety device. The entire system is built completely around the concept of personal, exclusive control over that hazardous energy. You never, ever rely on someone else's lock to protect your life.
We see this concept play out most clearly in group lockout scenarios. Even if a primary authorized employee locks out the main energy source, or maybe a shop lock is employed to lock a box with multiple keys inside it, or a multi-lock hasp is used, it doesn't matter. Every single individual working on that equipment must walk up and affix their own personal lock to each lockout point, or onto that gang box. They have to keep the key in their sole, and I mean SOUL, possession, and they're the only ones who can remove their personal lock when their portion of the work is finished.
And this rule of individual control scales across literally everything. Take something as simple as a plug-out device used to isolate a cord end. Whether you are working on a massive, highly complex stamping press with a whole group gang box, or you're just securing the plug of a single machine inside a yellow casing, that rule of one lock, one key, one sole applies universally across the board.
Because individual control is so absolute, there is no such thing as a standard master key in LOTO. If a worker goes home and accidentally leaves their lock on a machine, the employer can't just casually snip it off to keep production moving. They have to follow a strictly documented procedure. First, verify the worker is entirely off-site. Second, make all reasonable efforts to contact them directly. And third, ensure the employee is explicitly informed that their lock was destructively removed before they ever set foot back on the floor to resume work. When we step back and look at the complete picture of hazardous energy control, it's really a beautifully structured system. OSHA provides the absolute minimum frameworks, 1910.147 for general hazardous energy, and 1910.333 for specific electrical premise wiring hazards. Within those strict boundaries, the company writes the indisputable Bible of rules. And finally, the individual authorized worker executes those procedures on the floor using their personal lock to guarantee they are the ones in control, ensuring they return home safely.
So, I want to leave you with a provocative question to take back to your own facility today. Is your 3 a.m. LOTO policy explicit enough to save a life? Think about it. If a worker is alone, they're tired, and they're facing a complex machine breakdown in the middle of the night, does your training and your written policy truly empower them to isolate every single ounce of hazardous energy flawlessly? Take a really hard look at your programs. Thank you so much for joining me on this explainer today. Stay safe out there, and I will see you next time.